Hi, warm welcome to day number 20 of our daily life challenge. I'm extremely happy to see you all throughout the days and watching this live session and being with me. I'm really expressing my gratitude to each one of you. So, let us deep dive into a simple but uh, it is a simple concept, but I'm damn sure that most of the plus one students are not having clarity on this particular topic. So, what I'm telling you about is it is nothing about resolving uh, vectors into components, the application of which usually comes with whenever you are dealing with problems in laws of motion, work energy, power, and rotational dynamics, etc. In several situations, it comes. But many of the students, or let me put it in this way, in my experience, almost 70 or 80 percentage of the students are not aware of uh, the real science or real logic behind this. So I wanted to give you better clarity on this particular area. So let me share the screen without wasting your time. So let me move to the screen. See, this kind of slope and related problems are really, really common in physics, especially when you are dealing with the chapters like or topics like laws of motion, friction, similarly rotational dynamics, and many places related to many situations. These kind of uh, situation we need to analyze. So here, let me uh, let me help you. Let me help you track this code. Okay, usually this slope. When we consider this slope, we define the angle of slope. Let it be theta. Okay. Now we can see that there is a box placed on the slope. Yes, it is the box. Let me use some light color. Okay, so this is the box placed here. Now we wanted to find out the forces acting. Now we have discussed a similar situation in one of my earlier live sessions, but here I am emphasizing or something different. Okay, so we can consider the forces acting on this particular box. The first force which is acting normally uh, vertically downwards, which is the weight of the box. See, let me draw it like this. Let this be the weight of the box, which is acting vertically downward. So if the mass of the box is m, then mg, its weight mg is acting vertically downward. It is simple to understand because every object is being attracted by the earth towards its center, and that force will be vertically downwards. See, if you are falling from the top of a tree, you will be falling vertically downwards. Okay. In the case of a free fall. So, uh, in the absence of any other forces, the tendency of every body to fall vertically downwards. Why it is falling vertically downwards? In that case, the only force which is acting on the body is gravity alone. And one more thing is there, air friction is there, which is acting exactly opposite to the downward gravitational force. So mg is acting like this. Now, in all these similar situations, our interest is to resolve the forces into two components. One component which is acting parallel to the surface, because the possibility of this object is only to move parallel to the surface. The box cannot dig deep into the surface. It will slide down the slope, or it can slide up the slope with the help of some force which is pushing the box upwards. That is the only possible situations. So we are thinking about which force is acting parallel to the surface. In such a situation, we are not seeing any such force. So we are trying to resolve this particular vertical gravitational force. So I can resolve the force into two components like this. See, let me take this. Yeah. Let me take this, and with the help of this, we will be able to do it in a much better manner. Yes, yes. Let me take it here. Yes. Now I will be able to rotate it once again if needed. But there is some kind of problem. Yes, yes. Mm-hmm. 1 second. Yeah, let me keep that step, and I will do it manually. Yes. See, this is one component of this force, mg. And the second component, it is acting parallel to the surface, which is this one. Okay. Now, let me tell you the logic behind this. See why, and okay, why these two components, this one and this one, why these are called as the rectangular components? See, I wanted to give you some clarity. If you consider a vector like this, see, one vector like this, another vector like this. Let me name the vectors. This one, let it be R vector, this be A vector, and this be B vector. Here we can clearly say that R vector is the resultant of A vector and B vector. See, you imagine it like this. Consider someone starting from the point O. He is moving along the direction of A till this point P. Then he is changing his direction and moves along the direction of B till he reaches the point Q. Then ultimately what happened? The person who started from the point O has reached the point Q. That is the resultant, end result, final outcome of the process, whole process. So if you connect the starting point with the final point, you will be getting R vector, which is called as the resultant vector. In this particular case, A vector and B vector are the components of R vector, but they are not rectangular components. Why they are not rectangular components? See, I will be giving another scenario. I'm taking a copy, getting a copy of R from here, copy, paste. Yeah, let me take R here. Now I'm getting another scenario. See here. Let me change the color a bit. Yes, okay. Color has changed. Now you consider, sorry. Now you consider this one. This situation. I'm getting it. I'm placing it here. Now, let me reduce this. Let me increase slightly this one. Okay, now absolutely perfect. Now you consider if someone is starting from the point O, he is moving along the horizontal direction, that is the positive x direction, till this point P. Then he is moving along the y direction from this point till this point. Okay. Now, he has reached the point Q. Now, this is the vector R. Okay. Now, we wanted to consider this vector is identical to this one. See, same direction, same magnitude, no difference at all. So, if this vector is B vector and this vector is A vector, definitely this vector is also B vector, because it is having the same magnitude and same direction as that of the B vector. And now A and B are perpendicular to each other. Now, if I join the opposite side like this, what I'm getting? I'm getting a rectangle with the opposite sides as A and B. See, in this particular case, this side and this side are one and the same, A, same magnitude, same direction. And the similar way, the other two sides, this side and this side, are absolutely equal and opposite, having same magnitude, same direction. So, whenever R is considered, R is the resultant vector of A vector and B vector. Or in reverse sense, we can say that A and B are the components of R vector. But these are two special components. Why? A and B are perpendicular to each other in this particular case. So, since A and B are perpendicular to each other, we are getting a rectangle. That's why these are called as the rectangular components. Now, coming back to our original situation, let me erase all these things. Let me delete all these things for giving you better clarity. Yeah. Okay. Let us delete all these things. Yes. Okay. Absolutely perfect. Now you consider this particular situation. Here, this angle is theta, which is the angle made by the slope with the horizontal. It is theta. Now, this very same angle will be equal to this angle. Why it is so? You imagine a situation. Here, let us consider a line like this. And if we draw this line, now this line is perpendicular to the slope, right? Now, if I am bringing that line or rotating that line through an angle theta, okay, see the slope I have rotated through an angle theta and brought to the horizontal line. Now, you think about the vertical line. The vertical line will be nothing other than mg. See, if you extend mg like this, see from here, sorry, the whole triangle is moving. Instead, I will draw like this. See, if you extend this, it is perpendicular to this horizontal. So, whenever the horizontal is rotated through an angle theta, its vertical will also rotate through an angle theta. So, it is logically meaningful to understand that if this angle is theta, if this angle is theta, then definitely this angle will also be theta. Now, component which is adjacent to theta will be mg cos theta, and component which is opposite to theta will be mg sin theta. So this is the logic behind resolving a vector into rectangular components, especially when you are dealing with the slope problems. Okay, you will be encountering with the similar situations in many situations. Okay, that's it. So I hope that you got better clarity related to this particular situation. So why I am discussing here the real uh, fundamentals of physics. I'm not deep diving into the higher concepts. See, many of our students keep mugging up higher order equations, higher order problem solving methods like that, but they don't even know the fundamentals. So I wish you all to have strong fundamentals. Okay, so I would like you to attend my free webinar, which is called Physics Made Easy. It's a 2-hour webinar in which I will be decoding the various difficulties faced by students when they are trying to master the subject physics. And I will be giving you valuable insights, many outcomes from many researchers, and many valuable insights you will be getting from that free webinar, and it will definitely help you to level up your game. You will be able to master a subject like physics with passion, enthusiasm, excitement, joy, and lots of fun. It's a beautiful subject, but unfortunately our broken education system is not helping our students to master physics in such a beautiful manner. So I request you to, if you are interested to deep dive into a beautiful subject like physics, you can attend my free webinar, which is called Physics Made Easy. The link to register for the webinar is given in the description, uh, given along with this live video. So signing off, thank you for watching this live session, being here on the 20th day of live session. So again, once again, I express my gratitude to each one of you. Thank you.